So here we are. We have reached the end of all our factoring. We're going to do a bit of a factoring review. So by now you should know that there are 4 kinds of factoring. There's common factoring, there's easy trinomial, there's difference of squares, and last but not least is difficult or hard trinomial. And of course, there's any combination of these. You could have a common factoring and an easy trinomial. So your job is going to be how to decide what type of factoring. Because I'm going to be on a test or an assignment, they're all going to be mixed in together. So your first job is you always want to try to common factor first. You may or may not be able to do this, but try to common factor first. After you've tried to common factor, look at the number of terms you've got. 3 terms is special. 3 being tri, like a trinomial. So if you have a letter squared, and then just a letter, and then just a number, it's always a trinomial. It'll either be an easy trinomial or a difficult trinomial. If there's a number in front of the letter squared that you can't factor out, it's a difficult trinomial. So 3 terms. 2 terms could be a difference of squares. You will know it's a difference of squares if it's subtracting, thus the difference of squares, difference meaning subtracting in math, and it has to have a number that is a perfect square. They will always be a difference of squares, 2 terms with subtracting and a perfect square. Any other number of terms will only ever be common factoring. So if you don't have 2 terms or 3 terms, then you're stuck with only common factoring. So we're going to apply these ideas and do some factoring here together. So here's our examples. First one, the first thing I notice is that there are 2 terms. Next thing I notice or I remember is that I'm supposed to try to common factor first. So when I look at 15x squared minus 30, they will both divide by 15. So I write down my common factor of 15 and divide them both by 15, which leaves me x squared minus 2. 30 divided by 15 is 2. 2 terms. It could be a difference of squares. So I do a little check. Is it subtracting? Yes, it is. Is 2 a perfect square? No, it's not. 2 is not a perfect square. Numbers like 1, 4, 9, 16 are perfect squares. So I'm done factoring. Oh, one other thing at the top. Fully factor means there might be more than one type. So you may common factor and then do something else. So watch for that in instructions. All right, B. Crazy complicated looking thing. Definitely does not look like a trinomial even though it has 3 terms. But it's not a trinomial because it doesn't have an x squared, an x, and a number. So first thing we're going to do is try to common factor. So I look at all my terms, 36, 9, and 27. Start with the numbers. Common factor should be 9 for all those numbers. Then I look at the letters. I have an x cubed, an x, and an x squared. Lowest exponent is always the common factor. So x will be my common factor. Then I look at my y's. I have a y cubed, and a y. Lowest exponent is the common factor. Then I look at my z's. Z squared, z squared, z squared. All the same. So the common factor has z squared. So my common factor is 9xyz squared. And I'm going to divide each term by that. So I divide the numbers like normal. 36 divided by 9 is 4. To divide the letters, subtract their exponents. So x to the 3 divided by x to the 1, 3 take away 1 is 2. Y to the 1 divided by y to the 1. 1 take away 1 is 0. And z squared divided by z squared, 2 take away 2 is 0. Let's look at the next one. Don't forget your sign. See, I already messed up. Look at that. Watch my sign is minus. So it'll be minus. 9 divided by 9 would be 1. So I don't need to write that down. X divided by x. Y to exponent 3 divided by y. 3 take away 1 would be y squared. And z squared divided by y squared is 1. Last one. 27 divided by 9 plus 3. X squared divided by x. 2 take away 1 is x. Y divided by y. 1 take away 1 is 0. Z squared divided by z squared. 2 take away 2 is 0. There we go. Common factor. Look at what's in my brackets to see if I can factor it some more. There's 1, 2, 3 terms, but it's not a trinomial because I have an x squared and I have a y squared. So I'm done. That's it. No more factoring. C. Try to common factor first. Can I common factor? No. There's a 1, there's a 4, and there's a 32. So I can't common factor. But there's 3 terms. And one term has an x squared, one term has an x, and one is just a number, which means it's a trinomial. In fact, it's an easy trinomial because there is no number in front of x squared. Therefore, it's an easy trinomial, which means I'm looking for 2 numbers that add to -4 and multiply to -32. So I get my brackets ready. And what multiplies to -32 and adds to -4? That would be -8 and +4. Next one, try to common factor first. Can't common factor because 10 and 8 do not divide by 3. Then I count my terms. There's 3 terms. Is it a trinomial? Well, yes, it is, because there's an x squared, an x, and a number. And my trinomial has a number in front of the x squared. So number in front of x squared means, you got it, difficult trinomial. So depending on how you have been factoring a difficult trinomial, you could guess and check. Use the crisscross method. You can do decomposition, however you like. I think I will do this one by decomposition just to go through that method with you. So if we do decomposition, we're going to multiply the first and the last numbers together and we'll get 24. And I don't know why I wrote 34 when it is clearly 24. There we go. All right, and then you look for 2 numbers that multiply to get 24 and add up to 10. And those 2 numbers would be -6 and -4. And we decompose our -10 into those 2 numbers, keeping the other ones at the front and the end the same. Then we group in 2's and common factor. So 3x squared minus 6x have a common factor of 3x. So I have x minus 2. And 4x plus 8 has a common factor of 4. So I would have x minus 2. At this point, you check to make sure that you've got the same bracket, and I do. So one of my factors is x minus 2, and the other one is my 2 terms, 3x minus 4. So we've had a common factor. We've had another common factor that looks different. We've had an easy trinomial. We've had a difficult trinomial. Let's see what's next. So a squared minus 36, only 2 terms. Try to common factor. There's nothing in front of the a squared to common factor out, and 36 doesn't have an a to make anything common. So 2 terms could mean that it's a difference of squares. I look at the expression. Is it subtracting? Yes. Is the number a perfect square? Is 36 a perfect square? Yes, it is, because 6 times 6, or 6 squared, is 36. So it's a difference of squares, which is easy peasy. Get your two brackets going. They're exactly the same, except one is plus and one is minus. Away we go. Next one, two terms as well, but it certainly does not look like a perfect square because 12 is not a perfect square. So if it's not a difference of squares, then it must be common factoring. So what would be common? Well, there's no number other than 1, so we don't usually use it for common factoring. So I'm going to focus on my letters. There will be a common factor of A in each term and a common factor of B in each term. So I divide each term by AB, which leaves me with 12B minus A. And last two. 1, 2, 3 terms. No common factoring because there's no number in front of the x squared. So I'm going to look for two numbers that add up to 7 and multiply to -8. Get my brackets ready. Remembering my equal signs every time. So multiply till -8. 4 times 2 is 8, but that's not going to add up to 7. 8 times 1 is 8. So if I had a positive 8 and a -1, that would be -8 and add up to +7. Last one. Try to common factor. Can I common factor divide everything by 3? No. 17 does not divide by 3. Bummer. It's going to be 1, 2, 3, an x squared, an x and a number, a difficult trinomial. I'm going to do this one by the crisscross method. I'm going to look at my 3, and I know that 3 times 1 is 3. I'm going to look at my 10, and I know that 5 times 2 is 10. And so I crisscross and multiply. 3 times 5 is 15. 1 times 2 is 2, and I add up those two numbers and see I've got 17, which is good because that's my middle number. When it works, it's wonderful because there's my factors. 3x plus 2 and x plus 5. And you can always double check once you've got them factored. That is the beauty of factoring, ladies and gentlemen. Everybody should get perfect. Every time you factor, you can multiply out your brackets and check to make sure you've done it right. Okay, so your job now, there should be a factoring practice sheet. Good luck with that. Let me know if you have any problems.